Hi guys, and welcome to today's lesson on concentration. Today we're going to look at the different methods and the different ways you can calculate concentration depending on the units that you're given. Right, so let's get on with today's starter. What is a limiting reagent? Well, hopefully you realise that a limiting reagent it's the reagent that is used up first. You can also say the reactant instead of reagent, that's absolutely fine. Next question, what is the law of conservation of mass? Now this is similar to physics, where they talk about the law of conservation of energy. But in chemistry, where we talk about mass, we say that no mass is lost or gained in a reaction. Now the last one, what is the trend in reactivity as you go down group 1? Well, if you go down group 1, from top to bottom, reactivity increases. They start to get more reactive. Okay, let's get on with today's lesson. But before we get onto the calculations, you really need to know what is meant by these two terms. What a solute and a solvent are. Now I've put the answers below. A solvent dissolves a solute, and a solute is whatever dissolves in the solvent. Now if you think about sugar and water, the sugar would be the solute because it dissolves in water. Now when we think about concentration, it's good to know what a solute and solvent are, because as you'll find out later, concentration can be measured in grams per decimeter cubed, where the mass of something, the solute, is dissolved in water, a solvent. So if we have a look now at two solutions and think about what concentration might mean, we've got two things here. We've got orange particles, and we've obviously got more orange particles on the left than we have on the right. And we've got an equal amount of water. So let's say here we have 1 decimeter cubed of water, and here we also have 1 decimeter cubed of water. Once we dissolve these particles into the water, which one would be more concentrated? Well, hopefully you know that the one with the more particles will be concentrated. This one. And that's all that concentration is. It means that the more of a substance you have dissolved in a volume of water, a given volume of water, in this case 1 decimeter cubed, then you'll have a more concentrated solution. So, just to recap, concentration is the mass of a substance in a given volume. And the units of concentration are grams per decimeter cubed. That's what that line means, grams in a decimeter cubed. Now if we look at calculating this, it's actually not that difficult. We know that the units are grams / decimeter cubed. And this line here actually means divide, which is what this horizontal line here also means. The vertical one means multiply. So we can take the units and we can implement it and we can put it into our calculation triangle. We have grams divided by volume. So mass in grams divided by volume in decimeters cubed. And that will give us our concentration. And that's all you need to know really to calculate either mass, volume or concentration from any of those units. Now let's put this into practice. So we've got an example here. What is the concentration in grams per decimeter cube of a solution of sodium chloride where 30 grams of sodium chloride is dissolved in 0.2 decimeter cubed of water? Well, concentration is grams per decimeter cubed. Grams divided by volume. So grams is 30 grams divided by whatever the volume is in decimeter cubed, in this case 0.2. And if we do that calculation, we'll get our concentration, which is 150 grams per decimeter cubed. Not too difficult. And here's one for you to have a go at. Now it's slightly different in the way you're being asked to calculate mass. But if you use a calculation triangle, you shouldn't find it that much harder. Right, so hopefully you've had a go. And if we use our calculation triangle, I'll write it up here. Remember, mass in grams divided by the volume in decimeter cubed gives us our concentration. I'm going to write conc for short. And if we cover up the one we want, in this case mass, we'll see that it's concentration times volume, which we can do. So concentration times volume, 80 grams per decimeter cubed. I know that's the concentration because it's the units of concentration, multiplied by volume. So times by the volume, which is 25 centimeters cubed. Now in this case, we need decimeters cubed. So if I convert this into decimeters cubed, using this conversion here, we'll see that 0.25 decimeter cubed is the same as 25 centimeters cubed. And once you've done that calculation, you'll get 20 grams. Now there's also another calculation. You might see that sometimes concentration is given the units moles per decimeter cubed instead of grams per decimeter cubed. But don't worry, it's pretty much the same. As you've seen before, you can use the units to work out the calculation triangle. So moles divided by decimeter cubed, moles with the units mole for short, divided by volume in decimeter cubed, and this one will be our concentration, so conc for short, and the units will be whatever the units of concentration are that we are using, in this case moles per decimeter cubed. Now let's have a go at putting this into practice. So the first question says, what's the concentration in moles per decimeter cubed of a solution with 2 moles of salt in 500 centimeters cubed? Now if you remember your calculation triangle, you should be able to do this. You know that in order to get concentration, it is moles divided by volume. So conc equals moles, in this case 2, divided by the volume in decimeters cubed. Now our 500 here is in centimeters cubed. So in order to get that into decimeters cubed, we have to divide by 1000 and we get 0.5 decimeters cubed. And once you've done that calculation, you'll get 4 moles per decimeter cubed. So just to reiterate, going from 500 centimeters cubed to decimeters cubed, you will need to know that 1 decimeter cubed equals 1000 centimeters cubed. Okay, now the final equation we're going to look at today is how you convert between the two units, moles per decimeter cubed and grams per decimeter cubed, because sometimes you'll be given the information and asked to convert between these two, these different units of concentration. And all you need to do is remember this here. Just like before, you can put it into a calculation triangle, but it's probably best that you just remember the one equation. Let's have a go at using this now. What is the concentration in moles per decimeter cubed of a solution containing 3.7 grams of calcium hydroxide in a 0.25 decimeter cubed solution, effectively? So pause the video, try and work this out. It is tricky, and then unpause it for the answer. Right, the first thing to do is to see what we've got from the question. So we have a mass, we have a molecular formula which tells us we have the MR, and we also have here a volume. So we don't have any of the moles, we do have a volume, and we have the MR, and we have the grams. So it's probably best that we start by calculating the grams per decimeter cubed, because that's what we have. We have both the grams, the mass, and the volume in decimeter cubed. So let's have a go. To calculate grams per decimeter cubed, we do the mass, which is 3.7, divided by the volume in decimeter cubed, 0.25, and that gives us an answer of 14.8 grams per decimeter cubed. Now we have this number here, we can divide it by the MR, and that will give us our moles per decimeter cubed. So if you work out the MR of calcium hydroxide, this number here, we'll see that that actually gives us an MR of 74. So to put this all together for the final calculation, mole per decimeter cubed equals the concentration in grams per decimeter cubed, this one, divided by the MR, 74. Once that's calculated, you get an answer of 0.2 moles per decimeter cubed. Now that's all you need to know about concentration. You need to be able to calculate grams per decimeter cubed, and you need to know the other unit of concentration, how to calculate it in moles per decimeter cubed. And then finally, being able to convert between the two. I'm going to leave you with 4 questions now to have a go at. If you do need a bit more help with this, please put a comment in the box below and I will do another worked example or some more questions if you really need it. Okie dokie, thanks for watching.